Hi guys, in this episode of Shri series, we're going to be talking about difference of two squares and we'll look at the basic formula and also solve other questions involving difference of two squares. So what do we mean by difference of two squares? So two things you need to pick from here. The first one is difference and two squares. So the word difference means subtract, all right? So when you're looking at difference, you're trying to subtract two squares. So when you look at a square, for example, 4 squared, a squared, all right? So you're subtracting two numbers or letters that have a square attached to them, all right? So that's really what difference of two squares is. So if I was to give an example of a formula of how to apply the difference of two squares, the generic formula is simply a squared minus b squared, all right? So hence you got the difference as a minus side and two squares, a squared minus b squared. The formula is simply a minus b and a plus b, all right? So when you expand this expression a minus b and a plus b, you will get a squared minus b squared. So that's literally the formula for difference of two squared. If you're stuck, this is what you write in your formula sheet. Some people refer to it as a cheat sheet. So when you get a squared minus b squared, just remember it's a minus b, a plus b. All right. So what we're going to do is we'll look at a simple example that applies this formula. Say, for instance, you've got x squared minus 16. All right. Now, we know very well that there's a square there, but 16 is not represented with the square. But we know very well that 16 is a perfect square. All right, because the square root of 16 is 4. So what I can do is I can simplify x squared minus 16 as x squared minus 4 squared. All right, and now that becomes x minus 4, x plus 4. All right, so you can see it's exactly the formula here. So you've got x squared minus 16, and 16 is a perfect square because the square root of 16 is 4. So you're going to get x minus 4 and x plus 4. All right. Here's another example. Let's say, for instance, we put another expression, y squared minus 36. Now, I know very well that 36 is a perfect square because the square root of 36 is 6. So I could put y squared minus 6 squared, and that's going to be y minus 6 and y plus 6. All right, so that's how you solve questions involving difference of two squared. All right, the reason why it's a difference is you got a minus sign and you've got two squares in that. Okay, so let's move on to something slightly more challenging but involves the same concept here. Okay, suppose you've got 9a squared minus 4b squared. All right, now you've got numbers and letters combined in there. How do you solve that? Now, we know very well 9 is a perfect square and 4 is a perfect square. So what I can write down is I can say that's the same as 3a minus 2b and 3a plus 2b. All right, so what you can do if you want is, if you're stuck, you can just simply say that's the same as 3a squared minus 2b squared. All right, and therefore that becomes 3a minus 2b and 3a plus 2b. So that would be your answer. Let's look at this question here, 64x squared minus 25y squared. We know very well 64 is a perfect square because the square root of 64 is 8 plus or minus 8, and the square root of 25 is a plus or minus 5. So what we can do is we can rewrite that expression as 8x squared minus 5y squared, and therefore that becomes 8x minus 5y, 8x plus 5y. All right, and that's how we solve questions involving difference of two squares. You need to get two squares and find the subtraction sign, the difference between the two, and be very familiar with your squares and square roots. So for example, I knew very well 9 is a perfect square because the square root of 9 is 3. I also knew that 4 is a perfect square because the square root of 4 is 2. Same thing with 64 and 25, and the list goes on with, let's say, you could say 49, you could say 81, you can say 144, and the list goes on. All right, thanks for listening, guys. Bye now.